Thank you
so much. Yeah.
Thank you. All right. Good morning, everyone. I'm really happy to be here and be talking about how we apply machine learning at Square. I always like to start telling a little bit about myself, and hopefully, we all love natural language, although sometimes language is not the best method of conveying information. By the end of the talk, hopefully, you are not as confused as this poor guy receiving some directions. So I actually come from Barcelona, Catalonia, Spain, which I think is why I developed this interest in languages and natural language processing eventually, where I was very surprised that half of my classmates speak Catalan, the other half Spanish, when if you look at the history, as the Roman Empire extended throughout Europe, they were all supposed to be speaking, help me out, audience. Which language? Roman Empire. Latin, exactly, right? And yet it gave rise to Italian in one place, Romanian, French, Portuguese, Spanish, Catalan, all the languages that we now call Romance or Latin languages. And so its language is endlessly fascinating. We've been talking, like Francisco was talking about NLP. All languages have nouns and verbs, right? Which is not surprising because this is how we, as humans, perceive the world. There's sort of static objects, and then there's actions that we do. But the way in which you put these building blocks together, that's more arbitrary, right? In Japanese, you would say, the girl a book reads, which incidentally is also how Yoda talks, right? You kind of put the verb at the end for extra emphasis. But of course, in Japan, you also drive on the left, right? So certain things are societal conventions, whereas others are true human universals. So language is one aspect that I've always been interested in. And then the other one is sort of the computer science part comes from, I guess, kind of my dad. He was authoring some math books for middle school. And one day he showed up with an HP-85, one of the early home computers with a CRT monochrome screen, a card sheet for storage, thermal printer, and some manuals that taught you how to program, right? Basic at that time. So I ended up studying computer science, but then I realized, wow, there's this new field at the time called Computational Linguistics, now better known as language technologies, where we are now in between these this long trend, right? From the IBM shoebox, which was a voice-operated calculator. You could say something like 2 plus 3, and it would come up with the result. Of course, you couldn't say 4 plus 5, because 4 plus 5, I'm not making a pause between each word, right? It only was isolated word recognition. It was also speaker dependent. It would only understand the two engineers who built it. And of course, very limited vocabulary, right? Just the digits and the operators. And on the other sort of extreme is kind of the scenario depicted in the movie Her, if you've seen it, where basically we have such an advanced AI that we prefer as humans to talk to that AI as opposed to other humans, because they're imagine an AI that is able to ingest the entirety of Wikipedia, right? All of human knowledge, all of human history, and of course, importantly, be able to reason about it. Well, you may have then a conversation with that agent that is more captivating, more interesting than anything that you can have with a human that you would find them kind of slow and boring, right? So we're in between, and I think this conference is a good, emphasis on human-centered. We always need to remember, right? We need to build a society that we would want to be part of, right, as we advance in these technologies. So a cool example is that exemplifies how the field has changed and how ML is so powerful, specifically like deep learning, is in speech recognition. Here's a little test. This is 1 second of speech. It is called a spectrogram, so it's time in the x-axis, and there's frequency in the y-axis, and then the amount of energy in each frequency band. And this is a digit in English. Which one? Someone said, yes, 6, exactly, yes. And that is because, I don't know if I can point with this thing, but so it's basically noise in the beginning, so it has to be a so-called fricative, like shh, this is noise, right? Just sort of like white noise. It's all distributed across all the frequencies. And then there's a vowel that has these very distinct peaks and also transition. And then there's silence. There's like a micropause. Believe it or not, every time you say 6, you're pausing in between. Because otherwise, that's how you build the plosive. You need to build up some pressure, and then do the k to release it, right? So that's so-called plosive. And then you basically get the same noise again, right? So another fricative, in this case, 6. Of course, this is no longer done by hand. There's this sort of tradition, there were some people in the early days of speech recognition who would actually learn how to read these spectrograms, right? But we no longer have to do these manual rules. This is now being much more bottom-up, driven by the data, where we just have these, hours and hours of speech as examples, and then the outcome, which is, the phonemes, the syllables that we want to have. And for these particular tasks of sort of kind of low-level perception, neural networks are the perfect example of how much we've progressed. All right, this being said, I want to give a quick explanation about Square. You probably know Jack Dorsey because of Twitter, but actually he runs Square also, right? We've started by having these readers that make it easy for a small business to accept credit card payments. It used to be a very complex process to apply, a lot of paperwork, and then you would get this cumbersome hardware, and you have to pay a monthly fee regardless of whether you had any sales. So which is why Square became so successful. Even this lady on the right is using it. Who's that? Yeah, that's Emma Stone in La La Land. And now whether she won the Oscar for Best Actress because he was using a Square register, I'm not going to speculate. Correlation, causation, the decisions of the Academy are notoriously opaque, but it didn't hurt. Now, over time, from the little Square reader, we sort of evolved into and expanded into a whole ecosystem of services and products to basically make it easy to run a small business, right? We can do inventory management. We can even do team management, employee management with payroll and taxes. So that also means that over time, we've had much more data. And even though the company has grown sort of in headcount in a kind of a linear fashion, of course, if you look at sort of the cross-product of the increased user base and the increased functionality, you get this sort of gap, right, that has to be filled by mostly automation, which is when you know exactly what needs to happen, and then a little bit by machine learning, where you need a little bit of sort of more nuanced decision-making. So this is a chart that sort of tells a little bit historically, most of the ML application at Square has been for risk management. Anytime that you deal with money, you have to watch out for bad actors. And so you can imagine there's fake account takeover, buyer fraud, et cetera. But also, like, believe it or not, sort of phishing via marketing. Because as you expand your product, you also need to also watch out for, as I mentioned, bad actors. Turns out that Square Marketing, which is a really cool product that allows our sellers to have a conversation with their buyers through very professional-looking templates and doing marketing campaigns where they can promote a loyalty program or the latest product, well, sometimes it's being misused. Instead of being something like the offer on the left, it's a phishing attempt like the one on the right. Now, what do we have to do? Sort of machine learning to the rescue, right? This is an interesting example where there's this good sort of a heuristic or rule of thumb by Andrew Ng, one of the gurus in the ML field. He says, well, if we can basically automate anything that takes a human about a second of sort of human effort or human cognition, right? And here, as soon as you've seen a couple of these phishing attempts, you can realize that there's something odd, something different about these messages. And so some features that stand out are a couple ones. One is they always have a button that kind of a call to action, which is a button that includes a URL. And of course, you can see whether the domain of that URL matches the domain of the seller. That's kind of an easy one. A red flag if it doesn't. But also, we can look, and we're talking about NLP, you can look at the language. Turns out a lot of the language is very negative. It's like, problem with your account, urgent, as opposed to the more optimistic language of a normal marketing campaign. So in fact, we can use the so-called sentiment polarity, where you take a bunch of text and you match it from a scale of -1 sad to +1 happy. Now, so we've deployed this, and when sort of we're catching anything that looks suspicious, gets into sort of a queue for human review as opposed to being sent out automatically. Now, don't tell this to the bad guys. Otherwise, they're going to adapt and start crafting marketing campaigns that say something like, wonderful opportunity to freshen up your password, right? We don't want that. Now, this was one small example, but actually at Square, we have entire business units that are being powered by machine learning. The key example is Square Capital, where rather than us looking at any external FICO scores or stuff. We just look at how a seller has been doing within our platform, within our ecosystem, and we're able to sort of offer them loans to grow their business, right? And this is sort of uncovering of opportunity that is very much data-driven. And so, yeah, we've sort of extended more than 5 billion of these merchant loans for merchants, with the average being $6,000, right? Which is, of course, very small for a traditional bank. They would rather go for the jumbo mortgages. But that's also because they have much more human overhead, right? If you have it all automated, then there's no difference. Now, this is a good point to now look at a little bit about sort of the accuracy, right? Because there's always this question about, well, you know, is this model accurate enough? What does it mean? And basically, the key message is, probably most of you already know, but to realize that accuracy is not really a single number. You rather have to pay attention to the kind of the two types of mistakes that you can do, right? The so-called false negative, which is in this case, the model predicted that we should not issue a loan. Maybe they were too risky, but in fact, they've proven to be a good seller. Or the other one, a false positive, which would turn out to be kind of a delinquent loan. We facilitate the loan, but then it doesn't get repaid. The point here is that if you look at, you know, like a perfect oracle, we would go around and select something, you know, of picking the positive instances while leaving all the negative instances out. In practice, any classifier is going to have some built-in sort of bias. And so for the sake of the example, imagine that the model has to be a circle. So all that we can play with is the center and the radius. Now, in this case, you know, how do we do? Well, we captured, in this case, 10 correct examples out of 15. So we have a so-called precision of 66%. But also, there's a bit of a problem because we have a lot of good guys outside, right? A lot of sellers that would benefit from a loan that we didn't pick. So in this case, a lot of false negatives. Now, who can tell me a quick and dirty way of improving what's called so-called the recall? I mean, like not having so many false negative outside. What can we do to the circle? Yes, we expand it, we make it larger, and then voila, our recall is now 88%. But of course, now this has had the unfortunate side effect of the precision being lower because now we also have many more false positives that we've captured. Then we can sort of get a little bit scared and say, oh, no, we need to be much more conservative and do the opposite. And then our precision goes up, but then recall goes down. The main takeaway is that it's really a trade-off. And in fact, you can plot it. You can plot this sort of precision, like more emphasis on the true positives versus recall. But the key thing is, well, how do we weight these things, right? Because in the absence of any other information, you might think that kind of equal error rate is the best thing to do, but that would implicitly assign the same cost to a false positive as to a false negative, when in practice, it's hardly ever the case. So you need to always look at the business context of what does it mean to have a false positive and what is the cost associated, and then compare that to the false negative, and then you can adjust. Now, this, in addition, if we're talking about sort of facilitating loans, interpretability is also a question. I'm sure some of you might know about GDPR in the European Union or CCPA in California, which are these sort of data protection laws that also give some rights to consumers. And one of them is to understand why certain decisions were made. And so that may also mean that in some cases, you may want to prefer certain types of classifiers that make it easier to generate an explanation. So for example, a decision tree ends up having this very, at the top right, ends up having these very squarish rectangular looking decision surfaces because it's questions like, it's binary questions, right? So has the seller been with us for more than 1 year? Yes or no? Is there GPV over $250,000? Yes or no? And so you can then understand why a decision is made, right? As opposed to say what is one in the middle, this radial basis function of a support vector machine, that it's able to carve a more kind of accurate decision surface, but then it also makes it harder because then you get this request of, why was my loan denied? oh, well, because factor x256 is above 0.7, right? And you're like, well, I don't know how to interpret that, as opposed to saying, well, because you haven't been with us long enough. Now, having said that, again, there's also some really cool research where in the not-too-distant future, we might be able to have a natural language module that is able to generate these human-readable explanations based on kind of any model, right? And there's some research here. This is not about loans, but about image understanding, where it can give you the reason of what they're doing. Soccer, they're playing soccer because they're kicking a ball, or the elephant is actually walking because it's the bent is knee. The knee is bent. All right, so then I want to illustrate, because now you might think, OK, this is really cool. I want to use machine learning to power a feature. So let me give you an example of catalog suggestions. And these are what I believe are the 4 key aspects that you want to make sure that you think about when you're thinking of deploying a feature, a machine learning-driven feature. First of all is the design. Like, how is the experience going to look like? And specifically, how is it going to appear when the model makes a mistake? Because it's not a matter of sort of if, it's a matter of when. By definition, if it's machine learning, it will at some point make some mistake. Otherwise, it's pure automation, which is much better. Like, if you don't need to go through the process of creating an ML model because you already know some exact, heuristics or rules, that's better. But we're talking about ML where you're making these sort of decisions on the fly based on data. You are going to make some mistake. Then the question is, what do you do with this incorrect prediction behavior? The other aspect is modeling. What are the signals and the features and how you build the model? Then the third part is engineering. How do you do something at scale? As Francisca from Uber just was talking about, sometimes your best model is very complicated, and it would not really scale for millions of the decisions that you need to do in one day. So the engineering aspect is also important. Robustness, latency, throughput. And then also you want to have analytics built in, not as a sort of as a sidecar, but as part and parcel of how you're measuring adoption, and also capturing the data in a way that it feeds back into the model. So to illustrate that, I want to give you the example of item suggestions in the catalog. So most of our sellers just kind of at the checkout, they just enter the amount. But of course, it's faster if they have a catalog of items. So instead of entering $12.99, they can just tap on T-shirt, right? And so we want to incentivize them to itemize. So if we know that they're, let's say, a bakery, which incidentally, we can know that they're a bakery also based on some machine learning model that infers their business type based on the business name. So of course, if you're Josephine's Bakery, you're probably a bakery. But even our model is smart enough to know that if the business name is Rolling Scones, you're also a bakery. In any case, you're a bakery, so we make some suggestions, right, of stuff that you may carry, like croissant or cookies. And then we suggest also a category, and we suggest variations, chocolate chip, peanut butter. And for that, we came up with a design. It's also important to make a visual distinction between kind of actual data and suggestions. In this case, we come up with this green pill. And then something cool about the modeling, we also basically treat the union of all of our sellers' catalogs. We can make some cool models based on also NLP and specifically word-to-vec, where we can create these vector representations of the words so that even though, for example, in general English, large and small are kind of opposites of each other, within the context of these catalogs, they're very close semantically because they're both being used to model size, right, and in the attribute of size. So it could be, so if you create a new item called T-shirt, we're going to suggest variations small and large. If you create a new item that is coffee, we can also suggest small and large based on these aggregate data. Then on the engineering side, it's also interesting, from the way that we work, a lot of the data science frameworks are mostly sort of Python, but then the engineering at scale still, there's quite a bit of Java, at least at Square. And so we have to kind of marry both aspects. And then analytics, as I mentioned, we want to have a good understanding of how the feature is being adopted. And we want to make sure that there's this feedback loop that when we present the suggestions, we see how they're being received, and that also feeds into the next iteration of the model. And so if you do all that, I claim that you're going to sort of have the wow square, because you'll be able to create kind of remarkable experiences for your customers if you pay close attention to these 4 aspects, which, by the way, can also be part of a kind of a broader approach. At Square, we're trying to, what we call, adopt a machine learning mindset, which includes providing ML training, doing brainstorming. As our first speaker this morning, Rachel, was mentioning, the people who know the problems best are the ones that are working with it already, right? So we have these brainstorming sessions where we say, ML, what could ML do for your team or your customers? And then come up with kind of a ranked list, and then you can prioritize, which typically leads to the third point, which is you want to treat data as a first-class citizen. And by that, what we mean is, in the same way that you typically put a lot of care in the definition of the functionality of a product or an API, you also want to have that same level of care to the data that it generates, so that it generates in a sort of a friendly way so that other services can consume and make it useful. Which then allows us this fourth point of then weaving ML as really sort of integral part, like in the example of the item suggestions, not as a bolt-on analytics, but rather as something that is inherent to the way that the services operate. And of course, all of these sort of grounded in an ethical and principled application of ML, which is something that the entire industry is still sort of working out. But we certainly agree that it should be fair in the sense that some sort of a notion of equality, equal opportunity. There's some nuances, because you need to make some trade-offs about what does equal opportunity mean. But in any case, it should certainly be accountable, this idea of being able to explain what the models do and how they perform. And finally, it has to evolve and make sure that we keep a dialogue open with society and understanding the implications that all of these models have, so that, as I mentioned before, we all collectively build a future that is very much ML-driven, but also a future that we would want to be part of. And with that, I thank you so much for your attention.
Thanks so much, Marcel. Thank you.